All right, so let's look at another real life example. Here I have another problem, but it's going to be a little different type of formula. We're not going to use the A equals A naught E to the KT. We're going to use a thing called Newton's law of cooling / heating. And I'll show you the formula here in a second. So here it says, a frozen pizza with a temperature of 28 degrees Fahrenheit is placed in a room with a steady temperature of 75 degrees Fahrenheit. In 15 minutes, the temperature of the pizza has risen to 36 degrees Fahrenheit. How long will it take the pizza to reach 50 degrees Fahrenheit? So I need to know a time. I'm looking for a time. So at this point, you need to know Newton's law of cooling. So Newton's law of cooling is going to be your temperature based on time is your temperature of your surrounding plus the temperature of your initial minus the temperature of your surrounding, e to the kt. All right, and once again, if K is positive, it's heating up. If it is negative, it's cooling down. So when in context of this problem, I should expect something along the line. Well, we'll just solve it and figure it out. All right, now, so capital T is going to be temperature in this formula. So my T sub S is my temperature of my surrounding. Can't spell. My T naught is my start temperature. E is Euler's constant, K is a constant, T is time. All right, so let's dive in and solve this problem. Let's see how long it's going to take that pizza to heat up to 50 degrees Fahrenheit. All right, so I've written down the information here. We've got Newton's law of cooling / heating. T of T equals T sub S plus T naught minus T sub S, all times E to the power of KT. And I wrote down the bit of information that we need initially. We know that the pizza is originally 28 degrees Fahrenheit because it's frozen. The surrounding temperature of the room is 75 degrees Fahrenheit. After 15 minutes, it's up to 36 degrees Fahrenheit. Now, we're ultimately looking when T of T equals 50, we're looking for T. That's what we're ultimately looking for. So I need to solve for K first, just like in the half-life problem. Once I have K, then I can go back in and solve for T. So let's just plug in what we know. I've got T of T for 36. I have 36 equals my temperature of my surrounding is 75 plus my T naught's 28 minus the temperature of my surrounding, 75, e to my, let's do 15k, because my T is 15 and I don't know K. So I need to solve for K here. So I'm going to subtract 75 from both sides, and I'm going to get negative 39 equals, well, we can simplify this down to negative 47 e to the 15k. I divide by negative 47, I get 39 over 47 equals e to the 15k. We ln both sides. And this just gives me 15k. So therefore my k equals ln of 39 over 47 over 15. This is actually a negative number, simply because this is less than, it's greater than 0, but less than 1. Therefore, this is going to end up being a negative number. So my k is actually negative here. All right. So now I know what k is. I'm ready to go ahead and see how long it's going to take this pizza to get to 50 degrees Fahrenheit. All right. So let's finish this out. Now I know T of T is going to be 50, because that's the temperature, my target temperature I need to know the time for. I know my temperature surrounding is still 75 plus my initial temperature is still going to be 28, and this is 28 minus 75, which was what, negative 47? Correct. Let me just write it in first before I actually do the numbers. So we're going to do 28 minus 75. Now I know my K is, well, I've got E. My K is ln of 39 over 47 over 15 T. And all I have to do is solve for T. It looks way worse than it actually is. So we're going to subtract 75 from both sides, and I've got negative 25 equals, well, this is negative 47 e to the ln of 39 over 47 divided by 15 t. All right, divide both sides by 47. I've got 25 over 47 equals e to the ln of 39 divided by 47 divided by 15 t. ln both sides. We get ln of 25 over 47 equals, this just simply becomes ln of 39 over 47 divided by 15t. Whenever you have a fraction, you can just multiply both sides by the reciprocal. So I get t equals 15 ln of 25 divided by 47 divided by ln of 39 divided by 47. All right, that's the exact time, but I have no idea what that number is off the top of my head. And that is why we have a tool called a calculator. Let the calculator do the number crunching for you. When you do this, my t is going to be approximately 50.7 minutes. So this is approximately 50.7. So my times, it's going to take that pizza about 51 minutes to get to 50 degrees Fahrenheit. Not terribly bad. Now, where is this really? All right, where is this applicable? Why would this really even matter? Because nobody's sitting around pulling a frozen pizza out, taking the temperature, and say, hey, how long is it going to take to get to 50 degrees? That's kind of like just a made-up type of question we can do the math on. The math on is pretty simple. But let's really think about this when you come dealing with food safety. It would be really nice to know how fast that temperature is getting into that danger zone where food can no longer be safely preserved. So this is where you start getting into real life, actual real life applications, because with the math behind it, you can actually figure out if you have something at 200 degrees, and we know bacteria grows at a set temperature range, ideally, we can calculate how long that can be on the counter in an average room temperature and say, hey, you have this long until you have to put it in a refrigerator to get it cooled down quicker so bacteria is not growing, so you don't waste food and get food poisoning. So that's just one example of this. There's many, many other examples. There's another problem I'm going to have you guys work where you're going to actually figure out the time of death of somebody by using the person's body temperature as it cools down after they've passed away. Compared to the room temperature, you actually be able to approximate how long ago that person had passed away. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.